So what I want to do today is talk about domain and range, right? So let's take a look at number one here. Number one, we've got this graph. Can anyone, well, first off, does anyone remember what domain is? Not for this particular graph, but just in general. What is the domain? What are we asking about if I ask for the domain? What am I looking for if I'm looking for domain? Yeah?
Is it like the distance between the smallest and the largest number?
No, that's the range, but only the range when we're talking about like a set of data, when we're talking about like mean and median and mode and range. So that particular definition of range goes with mean, median, mode type stuff. But good thought. Domain. What is the domain? What does it mean? Oh, how quickly we forget. Starts with an L. Ends with ist of all x values. List of all x values. Very good. Okay, so the domain is basically all of the x values that we're using in a graph. Okay, so for this particular graph, what's my domain? The what?
Wait, for which graph? For this graph?
For this graph, number one. That graph right there. What's my domain?
The x values.
Which are?
3, -3, 2, -2, -1.
So just the -3, the -2, the -1, the 0, the 1, and the 2. That's all the x values I use in that graph. If that were true, then I wouldn't have connected the dots. When I connect the dots, I'm telling you that I'm using also all of the x values between -3 and +2. Between -2 and -1. Between -1 and 0. So I'm also using the x values -1/2, -1.5, -2.367. Right? That's what connecting the dots means. So what x values am I using in this graph? Every number what? What was the last part of that? I just didn't catch it.
Really?
Every number, really. In other words, every, starts with an R. Not rational. Go up one. Real. Right? Every real number is being used in this graph as an x value. Okay, does that make sense?
No.
Okay, so let's talk about it. We have, on this graph, we have arrows at the end of the graph, correct? Right? We have this arrow right there, and we have this arrow right here, right?
Yeah.
What does that arrow mean?
Continuous.
It goes on
Forever.
forever. So this graph just keeps getting wider and wider, right? So basically, if I drew my graph big enough, if I drew a line from 4, would I hit my graph eventually? Eventually I would. What if I came over to 50? Would I hit my graph eventually? What about 100? Uh-huh. Is there any graph, or is there any x value that eventually won't hit my graph?
No.
No. So I'm using every single x value possible in this graph. Does that make sense? Okay? So that's what we mean when we say all real numbers. Now, we have a couple of ways that we're going to write our domain and range. Okay, so domain is often abbreviated just to D, right, for domain. So one thing that we could do is just write the all real number symbol, right, which is the funky R. Today we're going to talk about a new way of writing it. It's called interval notation. And this notation uses infinity symbols. And we're going to go from negative infinity to positive infinity. Now, by negative and positive, I'm just indicating directions, right? This doesn't mean that the negative infinity is only the negative numbers. What it means is that I'm going towards infinity headed towards the left, right? So infinity going to the left that way. The positive infinity means I'm going towards infinity to the right. Does that make sense? Okay, so one of the things that I expect you to be able to do on the upcoming quizzes and tests is write domain like this. From negative infinity to positive infinity. We good? Just FYI, the domain on pretty much every single one of these will be all real numbers. There's not much that we do right now that changes the fact that my domain is all real numbers. Okay? Range, on the other hand, will change. Yes?
On the test, will you have to write the infinity signs, or you have to expect those?
So I will be expecting on the test that you can give me this version. This new version. Okay? This is called interval notation. Right? Okay. So if domain is the list of all the x values, then the range is all the y values.
Y values.
All right, so let's talk about the range. What's the range on this one? What do you got, Jake?
All the Y values between 0 and 10.
So my graph only exists from 0 to 10. I don't have any graph down here.
All real numbers.
And it's not quite all real numbers. Because if I come down here, right, if I go to negative 10, if I draw a line through negative 10 on the y-axis, do I hit my graph?
No.
No, I don't. Right? What do you got for me, Justin?
Is everything from negative 8 or above?
From negative 8 and above. Right? Now, there's a way that we can write this that we've written it in the past. Okay? How would I write y values that are bigger and including negative 8? Greater than or equal to negative 8, right? So one way to write this would have been to say that y is greater than or equal to negative 8. That would have been the way we would have written it in the past, right? That's my range. Y values greater than or equal to 8. What do you think we're going to do for interval notation? How are we going to show this using interval notation? What do you think, Justin?
You just write the parentheses and negative 8 on the positive.
Very good, except I won't use a parenthesis with the negative 8. We're going to use a bracket. So, we're going to go from negative 8 to positive infinity. The number gets a bracket. The parentheses goes with the infinity symbol. Okay? So, how are we doing? Does this make a little bit of sense so far? Domain range? Are we good? I like interval notation, right? When you get to Algebra 2, we're going to do interval notation, and we're going to do what's called set builder notation, which uses this particular method, but you'll have to be able to do them both when you get to Algebra 2. All right. Now, let's just take a quick look at another one. Let's go ahead and take a look at number 3 here. So here's this graph, right? What is the domain of this graph? What is the domain of this graph? Jake, what do you got?
All real numbers.
Okay. How do I write that in the new notation?
Parenthesis.
Mm-hmm.
Negative infinity to positive infinity. Parenthesis.
Very good. Negative infinity to positive infinity. Right? Okay. What's my range. What is the range on this one? Yeah, Kaylee?
Bracket,
Yeah.
-12. But then the data is still equals.
No,
Is it less, it's
neither.
even?
Yeah,
Just positive infinity.
positive infinity.
Oh,
You were kind of mixing the two of them together there. It's all good, right? So from -12 to positive infinity. All right. How we doing? We good? All right, let's check out one more. I want to go to number 5. Okay, so let's go to number 5 here. Okay, number 5. What is the domain for number 5? I want some new blood. Been getting a lot of help from Jake and from Justin. Let's get some new people out here. Mackenzie, thank you for volunteering. What do you got for me? Domain. Yeah, so far so good. Nope, that would be going the same way twice. From negative infinity to negative infinity to positive infinity. So we're going to go negative infinity. We're going to go positive infinity. We'll put the parentheses down and we're good to go. All right? So far so good? Okay.
Does it matter which way you put them?
Yes.
Okay.
Smallest one goes first.
Okay.
Smallest in value, right?
Yeah.
And as you move to the left, the numbers get smaller.
Correct.
So we put the smaller numbers first. Okay, range. What's my range on this one? I'm interested to see where we can go with this one. Justin, I'll take it.
Bracket 5. Oh, negative.
So close. So close.
Negative infinity or 5.
Yeah, we're going to go from negative infinity to 5.
You not
Right?
assume, say, small.
I did. We did just, he set me up pretty well for that, right? So the smallest number does go first. And because if I'm headed in the negative direction, my numbers get smaller. So I'm starting down here and going to the biggest thing, which is the 5. Does that make sense?
Yeah.
Okay, excellently done. You sort of fell into my trap. I apologize. But thank you for playing along. All right, now, so that's domain and range. You are expected to do this on today's homework. Okay? Just like this. Interval notation. When it asks for domain and range, this is what you do. Are we good so far? Okay, now, let's talk for just a second about what's going on here. This graph is opening down, correct?
Yes.
All right. It has a place where we stop going up. In other words, I have a value that is the largest. What's another word for largest value?
Greatest.
Greatest is good. I need another one.
Lot.
There's an M1.
Most.
Okay. There's another one. It's followed by an A. Maximum. The maximum value. Does that make sense? Right? So this graph, because it opens down, has a place where I stop going up and start heading back down. And so it has a maximum value. Does that make sense? What is the maximum value for this graph? 5, which was also the y value of your vertex. Does that make sense? Okay, let's go back real quick to, I'm going to go back up here to number 1. Now this one opens up, which means it has a place where I'm going down and then I stop going down and start going back up, which means it has a minimum value. Does that make sense? Okay, and again, the minimum value is the y value of your vertex. So far, so good? Okay, let's hop down to number 13, which you guys didn't do, but I have up here on the screen. So, number 13 has this information. It gives you the equation. And then it asks, do I have a maximum or minimum value? Okay. The first thing you need to know is, does this graph open up or does it open down? So, number 13. Does this one open up or down? This one opens down. How do I know?
Which negative tells you that? First.
If A is positive, remember, if A is positive, then it opens up. But if A is negative, then it opens down. All right? Don't forget that part. So in this particular problem, A is negative, which means this graph opens down. So does it have a maximum or does it have a minimum? It has a maximum, right? Because it opens down, there's a place where it stops going up and starts going back down. And so this one, for part A, I would put down that it has a maximum. Does that make sense? Okay. Now, the next thing to do is to state what the maximum or minimum value is. How do I find that? What did I say the value always was? It's the...
Isn't it part of the y-intercept?
It's not the y-intercept, it's the...
Y value.
Go ahead.
Y value of the vertex.
Y value of the vertex. It's the y value of the vertex. So I have to find the vertex of this equation, right? To find the vertex, we use the axis of symmetry. So we have a little bit of work to do for part B. So for part B, we'll go in here and start this process. X equals the opposite of B all over 2 times A, right? So then we have the opposite of 4 times 2 times negative, or divided by 2 times negative 1, which is going to give me negative 4 over negative 2, which is positive 2. That's the x value of my vertex. How do I find the y value? It's my favorite Glade song. Those Glade commercials. Plug it in. Right? You guys might be too. Some of you are like, commercials, what are those? A commercial, by the way, was the stuff in between parts of the TV show back when I was a kid. So we take this 2 and we plug it in to the equation. And so I get y equals negative, and then I'm going to square 2, and then add 4 times 2, and then minus 3. So 2 squared is 4, so I'm going to have negative 4 plus 8 minus 3, which is going to get me 1. Right? A positive 1. Okay? So my maximum value is 1. Does that make sense? Now, they do also ask for the domain and the range. And so the domain here is always, this is part C, the domain is negative infinity to positive infinity. Nothing's really going to change that anytime soon. That's my domain. My range, how do I know what my range is? Yeah. What do you think? And then it's the y value of the vertex. This one opens down, so we're going to start at negative infinity and go up to the maximum. And so we start at negative infinity and we run to my maximum, which was 1. We get a bracket there and a parenthesis there, and we're good. Okay? This is what I expect you to be able to do in your homework today. Okay? Now, your homework today is on page 549, same page. This time you're doing the evens. And this time you're doing everything.